Okay, let's be real. We hear about artificial intelligence all the time. It's everywhere, right? It's in our news feeds, it's recommending what we watch next, it's completely reshaping how companies work. But what's actually making it all tick? What's the engine under the hood?
Well, that engine has a name. It's machine learning. And honestly, getting a solid handle on what machine learning really is, that's the key to understanding where our whole world is headed.
Now, a lot of people use the terms AI and machine learning, or ML for short, like they're the same thing. But they're not at all. The easiest way to think about it is like this. Artificial intelligence is the big ambitious goal, the destination. And machine learning, that's the powerful method, the vehicle that's actually getting us there. So let's start at the very top. Artificial intelligence is the big picture dream. It's this huge field of study dedicated to one massive idea. Can we build machines that can think, reason, and learn? Kind of like we do. And this is where machine learning completely changes the game. See, the old way of doing things, you'd have to sit down and write millions of lines of code with hard-coded rules. If this happens, then do that. It was painful. But with ML, you don't do that. You just feed the machine a mountain of data, and the algorithms learn the patterns all by themselves. That means they can make super smart decisions about things they've never even seen before. It's a total game changer. So how in the world does a machine actually learn? It's a great question, and no, it's not magic. It usually boils down to one of three main teaching methods. So let's dive into them. First up, we've got what's called supervised learning. Think of this as teaching a student with a super detailed answer key. We give the machine a massive amount of data, where every single piece of information is already labeled with the right answer. The machine's whole job is to figure out the connection between the question and the correct answer. The best analogy is studying with flashcards. The machine sees an input on one side, say a picture of a cat, and is told the correct output or label on the other side is cat. It does this thousands, even millions of times, until it starts to learn the patterns and can identify a cat all on its own. Then you've got the complete opposite, unsupervised learning. In this case, there's no answer key. We just give the machine a huge, messy pile of unlabeled data and basically say, you figure it out. The goal is for the machine to explore all that data and find hidden patterns or groupings all by itself. Imagine someone dumps a giant bin of mixed-up Legos in front of you. What do? Without anyone telling you how, you'd instinctively start sorting them, probably by color or size or shape. You're finding the natural patterns. That is exactly what an unsupervised algorithm does with raw data. And finally, there's reinforcement learning, which is all about trial and error. Here, an AI, or what we call an agent, is put into some kind of environment, like a video game, and it has to figure out how to reach a goal. When it makes a good move, it gets a reward, like a point. If it makes a bad move, it gets a penalty. It's just learning from its own successes and failures. This is so much like training a pet with treats. A good action, like sit, gets a reward. A bad action gets nothing. Over thousands and thousands of attempts, the AI learns the best sequence of moves to get the most rewards possible. So just to do a quick recap, supervised learning is for predicting outcomes using labeled data. Unsupervised learning is for discovering hidden patterns in unlabeled data. And reinforcement learning is all about an agent learning the best strategy through trial and error. Each one is a powerful tool for a totally different kind of problem. Okay, so we get the learning methods, but how do you actually build one of these models? It's definitely not magic. It's a very deliberate process, a journey that takes you from a simple question to a powerful new insight. It all starts with asking a really clear question. But then comes what is often the hardest part, and I'm not exaggerating. This can be 80% of the work, collecting and cleaning the data. Real-world data is a total mess, and a model is only as good as the data it learns from. Garbage in, garbage out. Only after all that hard work can you choose a model, fine-tune it, and then finally set it loose to start making predictions. And understanding this process is a huge real-world skill. It's not just about getting a computer to spit out an answer. As this developer Xinwen Chang puts it, the real value is being able to evaluate the results and then explain them. That's what turns a cool technical project into a real business solution. All right, all this theory is great, but where does it actually show up in our lives? The truth is, machine learning is already shaping our world, a lot of times in ways we don't even realize. That movie your streaming service just knew you'd love, that's ML. The instant decision you got on a loan application, that's an ML model. It's predicting when factory machines will fail before they do, it's helping analyze doctors' notes to find insights, and it's guiding those little robots zipping around huge warehouses. This isn't science fiction. It's the invisible infrastructure of our daily lives.
And get this, it's not just for the Silicon Valley giants anymore. Not by a long shot. A recent industry survey found that a staggering 88% of companies are already using AI and machine learning. That means it's quickly becoming a fundamental, absolutely non-negotiable part of how business gets done everywhere.
And all of this leads us to one final, really critical question. We now know that machines will learn whatever we teach them based on the data we give them. The technology itself is neutral. So as we build this future, we have to decide what is the most important thing we should be teaching them.